Oh. So here I've got to make sure I read my instructions because it says find the value of y for the given value of x by first solving for y, then substituting the value x. Now, like, why would you do that when that's just going to make more work? It gets us into the habit of solving for variables. When we get into a slope-intercept form for a line, which we're going to see later this week, or solving for y to get to a parabola, or solving for an x-intercept, we're going to have that ability. I know you guys can substitute and multiply two numbers together and get an answer, but it's just getting into the good habits with those other things. So for instance here, we're always going to be solving for y. So I'm still going to do what I normally would do when I'm solving for a variable. I'm like, okay, I'm adding 3x to it. I'm going to subtract that. And I'm going to divide by 2. But here's where I would make a change on things. I would leave it in its fractional form as one big fraction instead of making it look like slope-intercept right now, because how I use it is every bit as important as getting y solved for. Here, I'm not using it to graph a line. I'm using it to figure out what the y value is when x equals 5. So once I get y by itself, when I isolate it, I'm going to go ahead and get that plugged in here so I can get to my answer. So for instance, here I can go, okay, so negative 3 times 5 plus 1 over 2. Now be careful. I'm assuming here most of you are probably just going to do mental math, figure that out, get the answer. If you do go to a calculator, again, be cautious, because if you just go whipping along and plug this in right away and don't really pay any attention to, grouping symbols, you might be going along going, okay, negative 3, 5, I'm just going to copy what I see, divide by 2, And you kind of start to look at that and you're like, well, I'm not sure that's right. To which I would say, well, I'm glad you thought of that, because it's not. Because if you think about it, and I forget that the denominator's there for a minute, negative 3 times 5 is negative 15, plus 1 is negative 14. Oh, divided by 2 is negative 7. That's not even close to being the same thing. What happened? What happened is the calculator followed order of operations. You didn't tell it that I want this and then divide by 2. So it multiplied these. Then it divided 1 divided by 2, and finally it added them. It followed order of operations. So if I was going to straight type this into the calculator, I would have to tell the calculator, I want this stuff. Whoa, not 2. That wouldn't help anybody. Done first, then go back and do the division. Which is why I don't like solely thinking the calculator's got to do everything. If I can come this way and do this mentally, calculator's a nice backup. That's about all it is on things like that. And then just number 2, and then I'm going to bounce down a little bit. This is another review from Friday. When you're trying to solve for y, I can't have y in the answer. So I need to turn these two y's and get it reduced down to 1. How can I do that? Okay? So since both of my terms have a y, I can do some factoring, and I can take a y out of there. By taking the y out, not only now do I only have 1, but I'm still going to have the same value for my problem. Y times x is xy. Y times negative 2 is negative 2y. Exactly the same value still. It's just now I only have one y, which is nice because since I'm solving for y and I'm multiplying by this quantity, x minus 2, now all I have to do is divide by it. And I have my equation solved for y. And I also have it in a good position. I'm plugging in 3 for x. Okay, 3 minus 2 is 1. 12 divided by 1 is 12. And I've got both pieces ready to go. So do be careful on instructions, because sometimes they can change from section to section. Problems can look exactly the same, but they don't quite end up being the same. So something to consider. Okay. The formulas again, take a look at a couple of these, 6 and 7, because 4 and 5 are pretty similar to some we've been doing. Here I want to work on getting H alone. Any suggestions on what we might do first to start isolating our H term? Because we do actually have options.
I would take the parentheses B1 plus B2 and take that and divide it by A on the other side.
Okay, I can absolutely do that right away. I could move this over and go ahead and do a divide. Now, the one question that we start to think about here is, I'm going to go with another sticky note here. Here's my one caution. When I'm writing this, okay, so I got H over 2. Is this B1 plus B2? If I had to make a choice and say that there was a fraction next to H divided by 2, where would the B1 plus B2 go? Is it up in the numerator or is it down in the denominator? Because that makes a little bit of a difference. Because as I look at that, and we're going to take a look at it both ways just to kind of see how this works out for us, it's interesting to note how this can become a little bit more interesting and look strange. So let's do it that way. Some of you are like, oh, he's going to do something odd. No, I'm just going to take up all my space here. I'm going to split this. We're going to take a look at this two ways. So let's say we divide first. Let's see if we get the same thing both ways. So if I divide both sides by B1 plus B2, that would basically cancel this out on this side and leave me with this. So what would my last step be then to get H by itself?
Multiply by 2.
Okay, so if we multiply by 2 on both sides, that 2 is only up in the numerator, so I'd end up with 2a over b1 plus b2 equals h. Now let's see if we end up with the same thing, trying something just slightly different in our order. And let's see if they're the same even. And then we can start kind of testing to see, now can both of these work, or sometimes are we going to have situations where something doesn't. So if I start back at my original, personally, when I went to do this the first time, I hate dealing with these, especially if I'm thinking I'm going to have to distribute. So I went ahead and I multiplied through by 2 right away. So you're going to notice, and part of this is going to look like the other one, because there's 2a. And you're like, yep, this is going to end up looking the same, because again, there's the h that I'm trying to solve for, but I'm multiplying it by this set of parentheses, this quantity b1 plus b2. So it absolutely works. And I just wanted to do that, not to put doubt in your mind, but to show you that on a lot of these, there's more than one way to get to the answer. So the worst thing you can do is nothing. So when you get to these, get in there, jump in right away, and give it a go. And 7 would work the same way, similarly to 6, in that if I'm trying to get this r by itself, dividing what's on the outside might be my best plan at the start. Because if I distribute, now I'm going to have more work to do. Am I still going to get to the right answer? I certainly could. Now, what would be my one last step on 7? If I'm looking to get capital R on a side by itself.
S over pi minus little
Okay? So, if I subtract the r, that would get me to the answer there. But again, just start with what's furthest away and kind of chip your way towards the variable that you're trying to solve for. It'll make life much, much easier on you. And then down at the bottom, same type of idea, except we're actually getting to apply it to something. So if I have something like, let's say number 9, where I've got the area of a rectangle's length times width, okay, it'll work the same as having the perimeter over here as 4 times s, okay, not s to the 4th, but just if you add 4 s's up, you get 4s. Solve for L, you're like, okay, number 1, solve for L. Well, shoot, I can handle this. I'm just going to divide by the w, because I'm multiplying by w there. So we'll divide by the w. Okay, so step 1, area divided by width is length. Well, then that makes step 2 pretty simple, because they tell me what the area is, they tell me what the width is, and that's the length. And whether you decide that you're going to keep it in a fractional form or go to a decimal, I don't care. But again, it takes something, geometry, or if you were doing carpentry work, you know, trying to figure out, I have this much carpet and I know the width of my room. Okay, now am I going to have enough for the length? You can figure that out. So it actually lets you do some application with that to try and make that a little bit easier. Any questions here on the front? Or is there 1 in 3, 4, 5, or 8 that you specifically want to take another in-depth look at here to make sure things are good? Because when I put my notes on the internet normally, I'll normally have all those other ones situated too, just in case you want to go back later and look. But I also don't want to sit you guys doing the same thing when you know what's up already. Like, nah, you're all right. Okay. So over to the back. Oh, story problems coming again. Okay. So again, we've talked before about putting math into language, putting it into words, and then kind of building it. And I'm going to start with a little bit trickier of a story type problem here that has a lot of pieces, but we're going to kind of break it down to make it a little bit easier. Sorry, we've got our lawn care business here. We want to know how much money we're spending on gas to travel. In a typical week, we're driving 600 miles and using 40 gallons of gas. Well, isn't this funny? Gasoline costs $1.25 a gallon. That must have been about 15 years ago. And your truck's fuel efficiency is 21 miles per gallon on the highway and 13 miles per gallon in town. Wow, that's a lot of info. But how much money I'm spending on gas? That's what I'm trying to figure out. So again, I kind of have to verbalize this. And it's not even, they're even breaking it down the highway and in town. So okay, let's try to turn this into language. Okay, so I'm doing some travel in town. I could call it out of time, but I'll just call it highway. So I'm doing some travel on the highway. Okay, and that's going to get me my total. So I'm looking at this and I'm going, okay, so I'm going to know how many miles per gallon I get, how many gallons of gas I use. Those are the two things that are going to come into play here. So I know in town, I get 13 miles a gallon, and on the highway I get 21. But here comes the part that seems kind of tricky. Because this money that I'm spending on gas is actually going to be the number of gallons, because they tell me how much it costs. So I'm like, okay, so if I use 40 gallons of gas, how can I figure out how many of the gallons are used in town and how many out? Or do I just put like it's 20 and 20, or do I guess and check? Is there a way I can make this a little bit more sensible? Let me ask a slightly different way. Let's make this real and then we'll go to the abstract part. Okay. I know there's 40 total gallons. And I know I'm doing some town traveling and I'm doing some highway. Okay. So let's say I know my highway mileage is 18 gallons I'm using there. How many would I be using in town? 22. Okay, if I was using 30 on the highway, how many would I be using in town? 10. You're like, okay, Harty, but this isn't helping us. You're just giving us guess and check. Okay, so let's say I tell you I'm using X piles per gallon in the highway. How many would I be using in town?
46.
Nice, okay. Because what you've been doing all along is you've been taking this number and it's like, oh, 40 minus 18 is 22. 40 minus 30 is 10. So what I'm going to do is I'm going to go ahead and I'm going to use this. I'm going to say, okay, I'm going to use X gallons of gas in the highway. I'm going to use 40 minus X in town. And I could do that either way. If I made this X and this 40 minus X, I'd actually get to the same answer at the end. And you're like, okay, but then I know that I'm using 40 gallons of gas, but what number do I put with it? Let's see what information we haven't used yet here. We know we drive 600 miles. We know we used 40 gallons of gasoline. 600 miles, 40 gallons. If I divide that, oh, miles per gallon. Just like the efficiency here. So they didn't tell us this. Ooh, that's not nice of them. But we can figure out, okay, I averaged, my total average is 15 miles per gallon. So some of it in town's 13. Some of it on the highway is 21. I don't know how much of either. But I know I'm going to average 15. Because 15 times 40 gets me back to my original 600. It lets me kind of visually see how this works. Now I actually got to solve this. It took long enough just to set it up, right? Because it looks like I've used all my values here, except the $1.25, which we'll do here in a moment. Bless you. So we'll distribute. And now I'm just straight up doing an algebra problem out of this, trying to get and find out what my x value is going to be, because then I can actually get this figured out. Minus my 520 over. Now you get to the point where you get, okay, x equals 10. That's great. So it looks like, so what's that 10 tell me? What does that x equals 10 stand for?
21 times 10 and 40 minus 10.
Okay. So it lets me know that I use 10 gallons on the highway, and it basically lets me see that I'm using 40 minus 10, or 30 gallons in town. And so this allows me a whole lot of things to start figuring out how much money I'm spending in town versus the gas mileage I'm spending on my highway travel, and vice versa. So this lets me see, okay, so if it's 30 gallons in town at $1.25, I'm spending $37.50 on gas in town, because I'd multiply it by the $1.25. And I'm spending about $12.50 on my long distance traveling. So it looks like a lot of my clients are in town. It's that type of information that can help you make business decisions. Maybe you want to start doing more highway. Maybe you want to do more in town. You don't know, but it kind of gives you that option to get things set up. Okay? Now, not every story problem you get in here is going to be long. Oh, please no. It will not be. Okay? These last three will take care of that for you. I just like to put the worst ones usually at the first so we can get the worst out of the way, make it a little bit easier on us.
Okay, now, what the actual problem said is it said that we wanted to know how much money we were spending on gasoline to travel in clients.
I knew you were going to say that
Yeah,
because...
I didn't say specifically which one. We could have just multiplied 40 by 125 and been done.
And I agree with that too, because as soon as we got to the end, I'm like, I'm having them do all these other things because I didn't put my other wording in. As soon as I looked at the end, I wanted to sit there and sigh and gasp and go, if I really read it, because exactly what you just said, how much money you're spending on gas, I could have gotten through all the junk. Wait a minute, for 40 gallons of gas at $1.25, it's $50 total. I don't have to do the breakdown. So actually, you just sort of gave me one there and said, goofball. You're like us. You did more work than you had to. I agree. I'm going to be more cautious on this next one. And I'm also going to make sure I'm really specific on my wording when I want the other stuff done, because I wanted to get to all this, and I didn't word that well at all. I needed to say that it needs to be split. That's a very good catch. And y'all can catch me on that later. Like, oh, dang, Harty's doing one of those things. That does happen to me every once in a while. It's true. I wish I could say it doesn't, but it does. Oh, it won't happen to the rest of them. So, here, on the next one, a little bit simpler. At least I'm going to make it simpler on myself. The table gives the height to the tops of the first few stories of a tall building. Okay, so let's see. The lobby, okay, top of the story is 20 feet. Story 1's at 32, then 2 is 44, and so on. Determine the height to the top of the 15th story. If I wanted to make an equation for this, even if I saw a pattern, my question to you would be, typically when we start looking at something like this, we want to find something that's linear. So if it's linear, it looks like something more that would be kind of like a slope-intercept form. So what patterns do you see as far as the change in feet depending on what story you're on? Okay? They just seem to keep going up by 12. So, as each one keeps going up, basically we're going to take our height will be whatever our base is from that one plus 12. Okay. So now, could I sit here and just, for the next 11, count up by 12s and get the answer? Sure. I absolutely could. But let's say I wanted to get something that was a little bit bigger. You know, what could I work with here? So, what's my base? Well, my base is starting in the lobby. You're like on story 0. You're on the ground floor. So when you're looking at that, you're like, okay, so if I'm starting at 0, and each time I'd add 12. So story 1, I'd be at 32, 44, and so on. So if I'm looking for the height of the 15th story, basically all I'm going to want to do is take my base, which is I'm starting with my 20 feet, and I want to add 15 more stories of 12 feet, because each story I keep adding 12 more feet to the top of that story. So I can make a little mini equation out of it. And again, I'm sure some of you could go super fast on that anyway, and just be like, yep, 12 feet of floor, 15 feet, that's 180 plus 20. And again, it's just trying to get you mentally getting into this type of setup. And if this is all going on in your brain, I'm good with that too. Okay? But sometimes just writing it down can help out when we're getting ready to do those. Or if we're trying to find out information with information that's missing. We've got a seating capacity of 2 airliners. We know Boeing can seat 100 more passengers than McDonnell Douglas. We know together they seat 696. Now we're going to set it up and we're going to solve it. So, well, what do I know? I know that Boeing plus McDonnell gives me a total of 696 passengers. But I also know that Boeing seats 100 more passengers than McDonnell Douglas. How could I write that as an expression using the variables? Because I'd like to get this down to one variable so I could solve it. Boeing seats 100 more than McDonnell Douglas. So if I said B equals, would this work? Boeing is McDonnell Douglas plus 100, right? If that's true, then I could take that M plus 100 and plug it in for Boeing, and all of a sudden I just have one variable to work with. Again, I could set up systems on this, but probably don't want to get into all of that. And I also could have done the same thing with McDonnell Douglas, but I'd have had M equals B minus 100 because I'd have 100 less than. But by getting it to one variable term, and now I can just solve this, and it'll let me know how many people could sit on the McDonnell Douglas plane but it wants to know, in this case, the seating capacity of each of the airliners. So I know that McDonnell's 298, which means Boeing is going to be 398 because they can hold 100 more passengers, and those two values add up to 696. And again, depending on the problem, sometimes I know some of you will be able to just whip these around your head, play with numbers, and go, yep, with some guess and check. I still want you to be able to do the setup in case sometime we get into something with decimals, fractions, something you may not be able to just whip off like that. It'll make it a little bit easier to be able to deal with those types of problems once we start doing some of the thought process with these. And then I save the easiest one for last. It figures. Rental car company charges an initial fee of $4 per ride plus 23 cents per mile. Write an equation that describes the relation between miles, M, and cost, C, in dollars. So, how much is it going to cost even if we technically rode 0 miles? I know you wouldn't, that wouldn't make any sense, but okay, it cost me $4 up front. That doesn't change. Whether I drive 1 mile, 400 miles, doesn't matter. It's $4 to start with. But my variable comes in with how far I drive. So how would I finish off this equation then? If it costs me 23 cents per mile, so if I drove 100 miles, I'd plug in 100 for M. Bless you. Multiply those together, add the 4, I'd know how much it costs to drive 100 miles, or 200, or 37, or whatever it happens to be. And here we're just setting up the equation. We're not trying to solve anything. We're not trying to do anything fancy or anything like that. So here's kind of our game plan that we're going to have running ahead here. Because I know you picked up 3 sheets. Okay, we got the note sheet done with 1. The quiz preview that you picked up, that's one over today and tomorrow. Start kind of picking through some of the problems, seeing how it's going. Like I said, those answers go up. Now this guy, okay, are word problems. Some of them you are going to solve. Some of them you are just going to set up an equation. It varies somewhat on these. There's going to be some more time to work with this as well as we're going. So they're not going to be big, huge, long, and awful, but it is something that's important enough that I'm not going to go to evens or odds on this one. This one we're actually going to kind of work through. So you've got some time today. Tomorrow we're just going to add in a little bit. So there'll be some more time with this. There'll be some time with the quiz preview, even though we'll thoroughly go through the quiz preview questions before we do the quiz on, I keep switching my days up, Thursday. I keep getting you guys in my algebra class, mixed up. And we'll make sure that we've got that, and if we need to get a little extra time on something here or there, we can. Okay? But this will end up being on the check, so you're going to want to get some of this done tonight. And if you need to come in and we need to do some together tomorrow, we can and let you finish those up. but this is going to be the last thing that needs to be done for your homework check. So make sure that you get yourself a good start on this one tonight. Any